In this video, we will going to take up one more problem on the development of lateral surfaces of solids. How to analyze this problem and solve it manually. A square prism of 30 mm side of the base and height 50 mm is resting with its base on HP, such that one of its vertical faces is inclined at 40 degrees to VP. It is cut as shown in the following front view figure. Draw the development of the lateral surface of the prism. So this is the figure wherein you want to cut the prism in this manner, wherein you have one plane is cutting from this point towards the left side and the other one is cutting from this point towards the right side till to the bottom of the base, such that one of the vertical faces is inclined at 40 degrees to VP. So why we are going to consider that now. So for that, first we have to take the initial position in this particular manner. A square prism of base, that is 30 mm, and height 50 mm is resting on its base such that one of its vertical faces being inclined to VP. So this is the one which is inclined to VP at 40 degrees. So if you get this, you have to take the initial position of the top view in such a manner that you will going to get the front view should be in this fashion. That means the dark line, the dotted line should be to the right of this dark line. So whether it is there or not, yes, the dark line is towards the dotted line is towards the dark line or right towards the dark line here. So here, so this is the position. If you take this position, then the dotted line will come to the right of to this dark line. So you have to keep that such that this vertical face is inclined at 40 degrees to VP. I cannot take this onto the right side because then the dotted line will going to come to the left and this dark line will come towards the right. So you cannot take that as the initial position. So you have to take it only in this way so that you will going to get the front view in this direction. So here first I need to consider whether this entire square prism is in true length or not. You can see the top surface A dash, B dash, C dash, D dash are all parallel to HP. So you are getting the true length, that is AB, BC, CD, DA, which is 30 mm. Similarly, P dash, Q dash, R dash, S dash, again it is parallel to HP. Therefore, PQ, QR, RS and SP all are parallel to HP. But whereas AP, BQ, CR and DS all are parallel to VP, therefore you are getting the true length in the vertical plane, which is 50 mm. Since all the sides, both in the shorter sides and as well as the longer edges, are in true length, hence we need not have to find the true length in the square prism. In general, any prism for that matter, we need not have to find the true length because it is already will be in true length. So how to start with the problem? First I am going to consider draw a XY line and you mark VP and HP. So in the top view, you take any point from there with reference to the horizontal, you measure an angle of 40 degrees and draw an inclined line. Then by using the compass, you take a radius of 40. Consider any point on that 40 degree line and you mark that point. From there, you cut an arc on this so that you will go to mark this point as D and this point as A. By using the protractor with the D as center with reference to AD, you draw a perpendicular by 90 degrees. And similarly with A as center, again with respect to AD, you measure an angle of 90 degrees and then draw a perpendicular to AD. Then again by using the compass, you measure the distance of 30. From D, you cut an arc on this 90 degree line or perpendicular line. Similarly from A also, you cut the same thing. And you mark this point as B and C. Join A to B, B to C, C to D and D to P and D to A with a dot line. Then again at the bottom surface, you mark that as small p, small q, small r and small s all are in bracket. Then from the XY line, you measure 50 mm and draw a horizontal line. Then draw a vertical projector from AP to the front view. Similarly from BQ, CR and DS till to the height of 50 mm above the XY line. Then you mark these points. As you look from the front view, ABC is near to the observer, so A dash, B dash, C dash is visible and D is away from the observer, therefore D dash will be in bracket. Similarly, P PQR is near to the observer, therefore P dash, Q dash, R dash is visible and S dash is away from the observer, so it will be in bracket. Then from B dash, according to the figure, from B dash you join to R dash with a dark line. Similarly, from B dash, you with reference to the A dash C dash, from B dash as center with reference to the A dash C dash line, you measure an angle of 30 degrees and then draw an inclined line so that it will going to cut it on A dash B dash. You mark this point, you dark this line, that is 30-degree line, and from here to here also you dark it. Then from this point to P dash you dark it. Similarly, B dash, Q dash a dark line, and then D dash is invisible, S dash is invisible. So this is a dotted line till where it cuts the section plane. From there till to S dash in bracket you make a dotted line. So and show the dimensions of the figure. So once you do that, so this is how you will be able to create the initial position of both the top view and front view of a square prism is cut by two section planes. And here, if you see whether it is in true length or not, yes, top surface is in true length and the bottom surface is also in true length, because all these small edges are parallel to HP, that is A dash, B dash, B dash, C dash, C dash, D dash and D dash, A dash. Similarly, P dash, Q dash, Q dash, R dash, R dash, S dash and S dash, P dash, all are parallel to HP. Therefore, AB, BC, CD and DA will be equal to 30 mm, which is the true length. Similarly, PQ, QR, RS and SP, which is also equal to 30 mm. AP, BQ, CR and DS are parallel to VP. So, AP will have a true length of 50 and similarly BQ, CR and DS. So, since you have both the shorter edges and all the longer edges are in true length, hence we need not have to find the true length. Now, I need to do the development without considering the section plane. So, how to do that? So, you take draw a horizontal from the top surface. Similarly, draw a horizontal line from the bottom surface also. And you consider any point from there, you start the drawing. So, you consider any point and draw a vertical line so that it will going to cut the bottom line also. And you mark this point as capital A and capital P. Once you do that, I want to open this AB, BC, CD and DA. So to do that, what is the side? Side is 30 because A dash, B dash is parallel to HP. So AB will be true length, so it is 30. Similarly, B dash, C dash is parallel to HP, so BC is also in true length. C dash, D dash is parallel to HP, that is also in true length. And DA is also in true length because D dash, A dash is parallel to HP. So from A, you measure 30 mm and mark this point. Similarly, from B, again you mark 30 mm and you mark this point. From C to D, it is 30. From D to A, again it is 30. Then, draw a vertical line from each of these points. That is from B to bottom line, from C to the bottom line, D to the bottom line and A to B bottom line. And you mark this point as capital Q, capital R, capital S and capital P. So capital PQ will have 30 mm and capital P to P is 120 mm. That is 30 into 4. So once you do that, after that this is the development of the square prism without considering the section plane. Once you start with the cutting plane, how it will going to consider that. Now, so the section plane, which are all the edges wherein the section plane is passing. The section plane is passing. The first point is we have to consider AP. If the section plane is passing through AP, yes, you mark that point as 1 dash. After that, you want to consider AB. So at the point B dash, you have one section plane. So you mark that point as 2 dash. Then after B, you have CR. So BC, you don't have section plane. So I want to consider on CR. Yes, CR is at this point. So you are going to get 3 dash. After that, you are going to have D dash, S dash. Yes, DS. So D dash is invisible, S dash is invisible. Invisible to invisible is invisible. So the 4 dash will be in bracket. Once you do that, after that, the section plane is coming and reaching at this point 2. And here, the 2 section plane is meeting. Since it is the 2 section plane is meeting, you will going to get a line here. You can see at the top view. and this is the point where you have the other end point as you look from the front view. So 2 dash is already visible and 5 dash will going to become invisible. So you mark that point as 5 dash in bracket, and that 5 will going to come on this here. Okay. So you mark that point as 5 dash. After that DS you have AB, AD. No, there is no sectional point passing through AD, but it is passing through AP. So you will going to get the point as 1 dash only. So this is how you will be able to write the sectional points. So I will repeat, the first section point which is here on AP, so you mark that point as 1 dash. Then it comes to AB. At the point B you have one more sectional plane, it is 2 dash. After AB you have BQ. Is BQ is passing through any section plane? B dash to Q dash? No. So then after that BC, there is no section plane is passing through BC. But at point R you have one more section point. So for that you are going to consider as 3 dash. After CR you are going to have DS. Yes. After CR you have DS where the section point is passing, which is 4 dash in bracket. After DS you have DA. So is the section point is passing through DA, but we have a point wherein D to A where the two section point meeting. So for that you are going to have the point as 5 dash. So this is how you will be able to name them according to the manner in which you have opened. So once you do that, then I need to transfer these points. How to do that? 1 dash is on A dash B dash, A dash B dash is in true length, so AP is here also in true length. So you draw a horizontal projector directly from here till to AP here. So you mark this point as 1 and you mark this point as 1. After that it is cutting on 2, therefore at the point B you have 2. Then after that we have the point 3 which is at R. So at R you have 3. After that you are going back, you are going to get D dash S dash. On D dash S dash slash you draw a horizontal projector wherein it will going to cut this point at D dash S dash. So for that you mark this point as capital D and capital S wherein you have the point 4. Then once you have that, then you need to consider this point which is 5 dash. Where exactly this point 5 dash? 5 dash is on D dash A dash, but where exactly the point which we don't know. So since this point is parallel to HP, so you are getting the true length here, so you mark that point as 5 here. So then how to transfer that? You measure the distance from A to 5, then you transfer it from this point to 5 here. So once you do that, you mark that point as 5. So then what I need to do, after transferring all these sectional points onto the development, then I need to join the development. So first what I need to do, I need to join the, how to transfer this point 5. So to transfer this point, you measure the distance from A to 5 and transfer it from A to this point and you mark that point as 5. So once you do that, you will going to join the numbers. So 1 to 2, 2 to 3, 3 to 4, 4 to 5 and 5 to 1. Once you do that, so then 1 dash to P dash is dark, so you dark between 1 to P and here also 1 to P. Then you have 2 dash to Q dash, so from 2 you mark this point Q. Then you have 3 dash at the top point, that is at the bottom point, it is R. Then after that 3 to 4 you have to join, and then 4 to 5 you have to join, and 5 to 1 you have to join. So since you have joined between 1 dash to P dash with a dark line, so you join between 1 dash to 1 to P and 1 to P. Similarly at 2 dash to Q dash, yes, 2 to Q. Then we have a 3, yes. Then it is 4 dash to S dash dark, so 4 to S. At the point 5 you have only the point, but you don't have the edge, because the point P, that point 5 will be on the rectangular face DAD SP. You can see AD SP on the vertical face. So that point will be at somewhere the distance from D to 5, which is 4.83 when you are taking from here. Otherwise it will be from A to 5, that is transferred from this side to this side. So once you do that, so then what I need to do, at the bottom surface all the edges are dark, therefore from P to P you dark it. So this is how you will be able to transfer the sectional points onto the development and join the completed development like this. So first what I need, join the numbers first. One should do that in the front view, which are all the edges which are dark. After cutting the section plane, make those edges in the development also as dark line. And since the bottom surface you don't have any sectional point is passing through that, therefore dark this line directly. So this is how you will be able to create the drawing, how to analyze the drawing on the square prism when two section plane is passing through each other at meeting at certain point on the top surface, and how to analyze that and solve by using the manual sketch. Thank you.